Okay, so here we have the simple plot of y equals 2x plus 4 from minus 3 to 3. The polar coordinates I'm not so great at zooming in on and getting the axes right, but at least you can see that this is a line. So this was our equation, 4 divided by sine t minus 2 cosine t. That's what you had. And that was the line y equals 2x plus 4. Okay. Here's the parabola. Am I on screen here? It's hard to get this one on screen.
That's off screen, the t.
Okay, so we have sine of t plus the square root of sine t squared minus 16 cosine t squared divided by whole quantity divided by 2 cosine t squared. And remember, you said we had a sine problem, but before we deal with the sine problem, at least it is a parabola, right? Even though I can't figure out how to, make it display properly. Let's see what happens if I make it a negative here. Because we did have 2.
Doesn't look like it changed.
So interestingly, it seems to still be a parabola. So it seems to be double covering the parabola somehow. So that's interesting. And then here we have the polar equation r equals cosine of 2t from 0 to pi.
Yep.
And then here we have the equation x squared plus y squared to the 3 halves equals x squared minus y squared. So what's the problem?
So we're not getting the other side of it. We're not getting the 2 that are up here.
Okay, so what do you think I need to do to get it to do that?
So maybe plus or minus?
Yeah, now why is this equation producing a plus or minus?
Well, the 3 halves, that could be either, because, well, this has to stay positive. X squared and y squared has to be positive because we're taking the square root.
That's right. So where's the plus or minus coming from?
Well, over here, it's the squared because you can have a minus x or the plus x or minus y or plus y.
Okay.
So the y, you have like minus 1 and 1 will go to the same y value, minus 1 and 1 will go to the same x value.
All right, well, let's look at the point. Let's say, I don't know. Well, it looks like this is the point, x equals 1, y equals 0. Okay, and so that corresponds to this one here, but I'm missing y equals 1, x equals 0.
Well,
so what happens down here when I put in y equals 1, x equals 0?
you get minus. You get minus 1.
Okay, so
instead of 1.
So where's the plus or minus coming from? Like why am I missing some solutions here? So if I just put a negative in front of this, I get that. So what's happening? Why are there 2 independent pieces or seemingly independent pieces?
Well, because you're doing the same operation to x and y. Like over here, they're kind of interchangeable.
Okay, but they're not interchangeable over here.
Yeah, you get the negative sometimes and the positive some other times.
But where is that coming from?
That x. Well, x going from minus 2 to 2 and y going from minus 2 to 2? Or
what's happening with this 3 halves power? Let me ask it that way.
you're taking the square root of x squared plus y squared and then cubing that result.
Okay, and what happens when I take the square root?
It becomes positive, or stays positive, I guess.
Okay.
And then cubing that will keep it positive.
Okay, but what happens when I take a square root?
You're taking the square root.
All right, so let me ask you a different way then. What is the square root of 4?
It's 2.
Okay. Are there any other numbers?
Well,
that
minus
when you square
2,
them, you get 4.
minus 2.
Okay.
So there's the negative square root is also a valid solution.
Okay. So the problem is coming from the square root.
But it just always goes to the positive one, not the negative one.
What do you mean?
There's always two square roots, there's always the positive square root and the negative square root, but it always goes to the positive square root.
What do you mean it always? I don't understand what you mean.
The
by it
square-
always goes. What
The
is it?
square root function will always take you to the positive square root.
In Mathematica, you mean?
Yeah, or just in general.
Okay. So the one way I can solve this is just by squaring both sides. I'm going to do x squared plus y squared cubed is this squared.
Okay.
Oh, sorry.
So the
I
minus.
still have the minus. There. Although now it looks like I have a plot point problem, but so
Yeah.
I have a sampling problem. But there I get both solutions now when I square both sides. But when I have that 3/2 power, the square root really should have a plus or minus, just like you had in the quadratic formula.
Mm-hmm.
So whenever you have a square root, really you actually have two answers, and that's what was showing up here. That's why there were two independent leaves.
Interesting.
All right, cool. Good job, man.